All right. Let's dive into some pretty cutting-edge AI research today.
Okay.
Specifically, we're going to be looking at Google's latest advancements in image and video generation.
Right.
They just dropped this blog post detailing some pretty impressive upgrades to their models, VO and Imagen.
Yeah.
And they've also introduced this new tool called Whisk.
It's remarkable how rapidly this field is progressing.
Yeah.
It seems like just a short time ago we were scrutinizing AI-generated content for telltale signs of artificiality, like blurry edges, odd artifacts, just a general lack of realism.
Yeah.
But what Google's showcasing here suggests we're entering a new era where AI can produce visuals that are not only high fidelity, but also deeply creative.
Yeah, you're right. The examples they provide in the blog post are quite striking.
They are.
I'm particularly intrigued by VO2, their upgraded video generation model. They're claiming it can now generate videos up to 4K resolution and several minutes in length, all from simple text prompts.
Yeah, that seems like a significant leap in capability.
It really does.
It is, and it's not just about the resolution and length.
Right.
What's really impressive is the level of detail and realism VO2 can achieve.
Yeah.
Remember the hallucination problem that plagued earlier models? Where you'd often see strange glitches like extra fingers or objects appearing out of nowhere.
Those were always a dead giveaway that you were looking at AI-generated content.
Exactly. Well, Google claims that VO2 has significantly reduced these hallucinations, resulting in far more believable and visually coherent videos. They've also made strides in terms of cinematic understanding, which opens up exciting possibilities for storytellers.
So what exactly do they mean by cinematic understanding? Can you give me an example?
Sure. In the blog post, they describe how VO2 can now interpret commands related to camera angles, lens types, and even specific cinematic effects. For instance, one prompt they used was to create a video of a scientist in a hazmat suit, shot with a slow zoom and shallow depth of field to emphasize her anxiety.
That's pretty cool. It's like having a virtual cinematographer built into the AI.
Exactly, and the resulting video, according to their description, effectively captured the intended mood and atmosphere through these cinematic choices.
Okay.
Another example they highlighted was an animation of a cartoon girl in a retro kitchen, where they specified a particular framing and focus to bring out her personality.
Nice.
So it's not just about realism. VO2 seems capable of adapting to different styles and visual languages from live action to animation.
Okay, that's impressive. And how widely available is VO2 right now? Can anyone try it out?
Not quite yet.
Okay.
They're currently running a limited beta test through their VideoFX tool in Google Labs, so there's a wait list to get access.
Yeah.
But they've indicated plans to integrate it into YouTube Shorts sometime next year, which would make it accessible to a much wider audience.
Interesting. It sounds like Google is taking a measured approach to rolling out these tools, perhaps to address concerns about potential misuse.
Yeah.
The blog post does mention their focus on responsible development and using SynthID watermarks to identify AI-generated content.
Yes, the SynthID watermark is a key element of their strategy to combat misinformation.
Okay.
It's an invisible watermark that gets embedded directly into the pixels of the generated image or video. What's remarkable is that it remains detectable even after modifications.
So even if someone tries to pass off AI-generated content as authentic, this watermark can help expose its true origins.
Exactly. It's like a digital fingerprint that can be traced back to the AI model that generated the content.
Okay.
Of course, no technology is foolproof, but it's a significant step towards ensuring transparency and accountability in this rapidly evolving field.
Makes sense. Okay, so we've talked about VO2 for video generation. What about their image generation model?
That's Imagen 3.
Okay.
And it's gotten some significant upgrades as well. The blog post highlights improvements in terms of brightness, composition, and detail. The images it generates are apparently more visually appealing and realistic than its predecessors.
And can it handle different artistic styles like VO2?
Oh, absolutely.
Okay.
In fact, they've expanded the range of styles Imagen 3 can work with.
Wow.
Think photorealism, impressionism, abstract art, even anime.
Okay.
It can seemingly handle a wide variety of aesthetic approaches.
That's impressive. Do they provide any examples in the blog post?
Yes, there's a captivating description of an image depicting a potter's hands molding glowing clay. The prompt specified capturing the energy of creation.
Okay.
And according to the blog post, the resulting image managed to convey that sense of dynamic movement and artistic passion.
Right.
They also mention an image of a red squirrel against a snowy landscape, showcasing Imagen 3's ability to handle contrasting colors and fine details.
It sounds like Imagen 3 has made some serious strides in terms of both realism and artistic flexibility.
Right.
What about availability? Is it easier to access than Veo 2?
Yes. Thankfully, Imagen 3 is actually available right now through Google Labs.
Nice.
They've rolled out their ImageFX tool in over 100 countries, so a lot more people have the opportunity to experiment with it.
That's great news for all the AI enthusiasts and artists out there who want to get their hands on this cutting-edge technology.
Yeah.
Now, before we move on, there was this other tool mentioned in the blog post. Whisk? What's that all about?
Whisk.
Hey.
This one's quite interesting.
Okay.
It's a new experiment they're running in Google Labs that lets you prompt with images to create unique visuals.
Prompt with images. What does that mean?
It means instead of using text prompts to guide the AI, you can input images to define the subject, scene, or style you want.
Yeah.
It's like showing the AI a picture and saying, create something inspired by this.
Okay, I'm starting to see the possibilities here, but how does the AI understand the images? Is it just analyzing the pixels?
It's actually more sophisticated than that. This is where Gemini comes in.
Okay.
Remember Gemini?
Yeah.
Google's powerful AI model known for its multimodal understanding.
Right, wasn't that the one that caused a stir because it could supposedly understand and reason about both text and images?
Exactly.
Okay.
Well, in Whisk, Gemini analyzes the input images you provide.
Right.
And generates detailed text descriptions of what it sees. These descriptions then become the prompts for Imagen 3, which uses them to generate a new image that reflects your visual input.
So it's like having a visual conversation with the AI. You're showing it images, it's interpreting those images in a way that humans can understand, and then it's using that understanding to create something new. That's pretty remarkable.
It is, and it opens up exciting possibilities for creative professionals, designers, artists, even filmmakers.
Yeah.
Imagine being able to capture the essence of a style or composition from an image, and then use that as a springboard for generating entirely new content.
That's a powerful concept. Do they give any specific use case examples for Whisk?
They do. In the blog post, they mention using Whisk to design a digital plushie based on an inspirational image.
Okay.
So you could imagine designers using it to rapidly prototype new product ideas or create variations on existing designs.
Yeah.
Artists could explore different stylistic interpretations of their work, and filmmakers could even use it for pre-visualization or concept art generation.
That's amazing. It sounds like Whisk could become a valuable tool for anyone involved in visual creative processes.
Absolutely, and it's only available in the US right now through Google Labs.
Right.
But I'm eager to see how creatives start using it and what kind of unexpected applications emerge.
Me too.
Yeah.
It feels like we're on the cusp of a major shift in how we create and interact with visual media, thanks to these advancements in AI.
I agree. It's a fascinating time to be following this field.
Yeah.
What strikes me most is how quickly these tools are evolving from simple novelty generators to sophisticated creative partners.
It's definitely raising some important questions about the nature of creativity and the future of art. But before we get into all that, let's take a closer look at the technical underpinnings of these models.
Sure.
How are they actually achieving these remarkable results? What's going on under the hood, so to speak? Okay, so we've seen what these AI models can do, but I'm curious about the technical magic behind it all. How do they actually take a text prompt and turn it into a photorealistic video or a stunning piece of digital art?
Well, it's all built on this foundation of deep learning,
Right.
which is a subset of machine learning that's inspired by the structure and function of the human brain. Specifically, these models utilize artificial neural networks, which are complex structures made up of interconnected nodes that process information in a way that mimics the neurons in our brains.
I remember hearing about neural networks, but it's been a while.
Yeah.
Could you refresh my memory on how they work?
Of course. Imagine a network of interconnected nodes organized in layers. Each node receives input from nodes in the previous layer, performs a simple calculation, and passes the output to nodes in the next layer.
Okay.
This process continues until the final layer produces the output.
Right.
In this case, an image or a video.
Okay, so it's like a chain reaction of calculations.
Yeah.
With each node contributing a small piece to the final output.
Yeah.
But how does the network learn to produce meaningful results? That's the deep learning part, right?
Exactly. The learning happens during training.
Okay.
Where the network is fed massive amounts of data, images, videos, and their corresponding text descriptions.
Right.
The network's connections and calculations are adjusted iteratively to minimize the difference between its output and the desired output as defined by the training data.
So it's a trial and error process where the network gradually refines its understanding of the relationship between text and visuals.
Precisely. The more data it's trained on,
right,
the more sophisticated its understanding becomes, allowing it to generate increasingly realistic and creative outputs.
That makes sense. Now, let's get a bit more specific. You mentioned earlier that VO2 seems to have a good grasp of cinematic techniques.
Yeah.
How is that achieved through these neural networks?
That's a great question. To understand VO2's cinematic capabilities, we need to delve a little deeper into the specific types of neural networks it likely employs.
Okay.
One key component is likely convolutional neural networks,
okay,
or CNNs for short.
Right.
These are particularly adept at analyzing visual data like images and videos.
I've heard of CNNs. They're used in image recognition and computer vision, right?
Exactly. They work by sliding a small window across the image or video frame,
Okay.
analyzing the patterns and features within that window. This allows them to identify edges, shapes, textures, and other visual elements that are crucial for understanding the content.
So it's like the AI is learning to see the world in a way similar to how our visual system breaks down images into their basic components.
That's a great analogy. And by stacking multiple convolutional layers on top of each other, the network can learn to extract increasingly abstract and complex features from the visual data.
Okay.
This allows to not only recognize objects,
right,
but also understand relationships between them, like the spatial layout of a scene.
Okay.
Or the direction of motion in a video.
Okay, that's starting to make sense. But video is more than just a series of static images. It has a temporal dimension.
Yes.
A flow of events over time. How does VO2 handle that aspect?
That's where another type of neural network comes into play.
Okay.
Recurrent neural networks, or RNNs.
RNNs, okay.
These are designed specifically to process sequential data where the order of elements matters.
Right.
Think of text, music, or, in this case, video frames.
So while CNNs are analyzing individual frames, RNNs are looking at how those frames relate to each other over time.
Exactly. RNNs have a built-in memory mechanism that allows them to remember previous inputs and use that information to influence their processing of subsequent inputs. This allows them to capture temporal patterns and dependencies, such as the movement of objects, the flow of dialogue, or the unfolding of a narrative.
So by combining CNNs for spatial analysis and RNNs for temporal analysis, VO2 can essentially learn to see and understand videos in a way that reflects both their visual content and their temporal dynamics.
Precisely. And during training, VO2 would be exposed to countless videos paired with text descriptions.
Right.
That might include information about camera angles, shot types, and other cinematic elements.
Okay.
This allows the network to learn the relationship between those textual descriptions and the corresponding visual patterns in the videos.
I see. So when a user provides a text prompt that includes instructions like slow zoom or shadow depth of field, VO2 can draw upon its training data to generate video frames that exhibit those characteristics.
Exactly. It's a testament to the power of deep learning to extract subtle and complex patterns from massive data sets.
Right.
And it's worth noting that the architecture of VO2 likely goes beyond just simple CNNs and RNNs. It might incorporate more advanced techniques like transformers, which have become increasingly popular for handling sequential data, especially in language modeling.
Transformers, those are the things behind large language models like ChatGPT, right?
Exactly. They've revolutionized natural language processing.
Yeah.
And researchers are now applying them to various other domains, including image and video generation.
Interesting.
Transformers excel at capturing long-range dependencies and relationships within sequential data.
Okay.
Which could be incredibly valuable for understanding the nuances of video and translating text prompts into coherent visual narratives.
That's fascinating. It sounds like VO2 is a truly sophisticated piece of engineering. blending multiple cutting-edge techniques to achieve its impressive results.
That is.
And while the exact details of Google's models are often kept under wraps for competitive reasons, the general principles we've discussed here provide a good understanding of how deep learning is being leveraged to push the boundaries of video generation.
Yeah, absolutely.
Okay, that's incredibly insightful. So we've covered how VO2 tackles video generation. What about Imagen 3 and its image-based counterpart? Does it rely on similar principles?
At its core, yes. Imagen 3 likely utilizes variations of CNNs and other deep learning techniques tailored for image generation. However, there are some key differences in how it approaches the task compared to VO2.
Such as?
Well, for one, Imagen 3 doesn't need to deal with the temporal dimension of video. It's focused on creating static images, so it doesn't require the same kind of RNN-based processing that VO2 uses for handling sequences of frames.
That makes sense. But you mentioned earlier that Imagen 3 can generate images in a wide range of artistic styles. How does it manage to capture such diverse aesthetics?
That's a fascinating aspect. Remember how we talked about training these models on massive data sets?
Yes.
Well, in Imagen 3's case, that data set likely includes a vast collection of images representing various art styles, from photorealism to impressionism, abstract art to anime.
So by exposing Imagen 3 to this diverse visual vocabulary, it learns to associate certain visual patterns and features with specific artistic styles.
Exactly. It's like teaching the AI the visual language of different artistic movements.
Right.
During training, the network learns to identify the key characteristics that define each style. The brushstrokes of impressionism, the bold colors of pop art, the clean lines of minimalism, and so on.
That's incredible. So when a user provides a text prompt that specifies a particular style, like create an image of a cat in the style of Van Gogh, Imagen 3 can draw upon its knowledge of art history to generate an image that reflects the requested aesthetic.
Precisely. And it's not just about mimicking surface-level features. The network also learns to capture the underlying principles and compositional techniques that characterize each style, resulting in images that feel more authentic and artistically coherent.
It's almost like the AI is developing its own artistic sensibility based on its exposure to the vast tapestry of human artistic expression.
That's a fascinating way to put it. And it raises some interesting questions about the nature of creativity and the evolving relationship between human and AI artists.
Indeed. It seems like we're entering a new era where the boundaries between human and machine creativity are becoming increasingly blurred. But before we dive too deep into those philosophical waters, let's circle back to the new tool Google introduced, Whisk. You mentioned that it allows users to prompt with images using Gemini's multimodal understanding. Can you elaborate on how that works technically?
Of course. Whisk's ability to prompt with images hinges on Gemini's remarkable capability to process and understand both text and images within a single model. This is what we call multimodal understanding.
Right. I remember that being a significant breakthrough when Gemini was first announced.
Absolutely. Traditionally, AI models were specialized for either text or image processing. But Gemini broke down that barrier, allowing it to analyze and relate information from both modalities seamlessly.
So how does that play out in Whisk?
Imagine you upload an image to Whisk, maybe a photograph of a scenic landscape or a piece of abstract art. Gemini analyzes this image, not just at the pixel level, but by identifying objects, relationships, and even abstract concepts it depicts. It then generates a detailed textual description of the image, capturing its essence in a way that humans can understand.
So it's like Gemini is seeing the image and then articulating its understanding in words.
Exactly. And this textual description then becomes the prompt for Imagen 3.
Interesting.
Essentially, Gemini acts as a translator, converting the visual language of the input image into a textual language that Imagen 3 can interpret and use to generate a new image.
That's a clever way to leverage the strengths of both models. It's like having a visual conversation with the AI, where you're providing visual inspiration, and Gemini is helping to bridge the communication gap.
Precisely. And this approach opens up some exciting possibilities. For example, imagine a designer using Whisk to create variations on a logo. They could upload an image of the existing logo and then use additional images to guide the style, color palette, or overall mood of the new variations.
That's a cool use case. It seems like Whisk could become a powerful tool for brainstorming, exploring different creative avenues and pushing the boundaries of visual design.
Absolutely. And it highlights a trend we're seeing in AI